Hello, everyone. Welcome to day 14 of the Machine Learning Teach by Doing project. In the day 13, we looked at feature representation and we saw how feature representation is such an amazing trick for transforming data points from a lower dimension to a higher dimension space and making data which was not linearly separable before, making it linearly separable in that higher dimension. We saw how you can transform data from one dimensions into two dimensions and make it linearly separable. We also saw a Python demonstration of how to transform data from two dimensions into three dimensions and make it linearly separable. Today we have another lecture on features in which we'll be looking at one hot encoding in particular. Broadly speaking, the lecture's title is Feature Representation Strategies. Feature representation strategies for various types of data. And one hot encoding is just one of these strategies, but it is very popular in ML literature. In fact, even when you do real life examples of an entire ML project, one hot encoding is very commonly used in so many projects that I needed to make a lecture to explain one hot encoding and what it really means. There are so many ML practitioners who don't have a clear understanding of why we need to perform a one hot encoding in the first place. As is the case with all the lectures of this course, we'll focus on fundamentals and make sure you really understand one hot encoding. So first, let us look at feature representation strategies and why they are even needed. So the main question which we want to answer is that how do you take data from a real source? So let's say we have data from a real source, which is like a real life data. So how do we take data from this? And then we need to put this data as an input to the learning algorithm, right? How do we do this journey? That is what we are going to learn in today's lecture. This journey of taking the data from a real source and encoding it as it is passed to the learning algorithm. So this is also called encoding. Now you might be wondering, why do we need encoding in the first place? Since we already have the data, why can't we just pass it to the learning algorithm? So let me come to that question with example. So imagine that you have discrete data, and I'm going to take two examples here. In the first example, the data which you have is the number of cylinders in a car. So that's the input data set. It can be 1, 2, 3, etc. So these are numerical values. But the second data set, which is also discrete, is the phone manufacturer which you have. So imagine you are collecting data from 200 people randomly, let's say in a particular city, and you ask them what phone manufacturer they have. And let's say the data is in four types. Either it is Apple, either it is Samsung, OnePlus, or the really outdated Nokia. Okay, that's the second type of data set. Now, the question is that let's say you have this data and you want an ML, you want to generate an ML algorithm, like let's say the perceptron algorithm or the classification, the random classifier which we saw, any ML algorithm. The question is, how do you take this data and feed it as the input to the ML algorithm? So the first option, which you might have guessed, it's the most obvious option. Option one is you treat the data as a numerical attribute. Treat the data as a numerical attribute. So this just means that, just if the data is in the form of numbers, just keep it like it is. So if, for example, if you are uh, doing, if the data is the number of cylinders, right, and the original data is 1, 2, 3, etc., you can just keep it like this. So you can treat the data as a numerical attribute. No need to encode it or transform it in any way. That's fine. But what about the phone manufacturer? Okay, you might say that I will do the following. So you say that uh, I will say Apple is equal to 1, Samsung is equal to 2, OnePlus is equal to 3, and Nokia is equal to 4. So I'll collect the input from every person, and if they say Apple, my data will be 1. If they say OnePlus, it will be 3. If they say Samsung, it will be 2. If someone else again has Apple, it will be 1. So the data will look something like this. Is this a good idea? This actually turns out to be a very bad idea. The reason it turns out to be bad is that it is not sensible to encode these as numbers, because they don't have any numerical representation or relation between them, right? If you say Apple is equal to 1 or Samsung is equal to 2, does it mean that Samsung is greater than Apple? Uh, no, right? So this will just confuse the ML algorithm. So if you upload, or if you use this encoding for such type of data, which is also called as categorical data. So categorical data is like this, which belongs to certain categories like either Apple, Samsung, OnePlus, or Nokia. So if you have categorical data and if you just assign numbers to this data, it is a very bad idea, because the ML algorithm gets confused. It might think that, oh, Samsung is 2 and Apple is 1, so Samsung is greater than Apple. It also might think that the difference between Samsung and Apple is the same as the difference between OnePlus and Nokia, which, so it might think that somehow these quantities are closer to each other or farther to each other. That's the biggest problem of directly representing them as numbers, especially with categorical data. So this does not really make sense at all. We cannot directly represent categorical data with numbers. And this comes up everywhere. Let's say if you have gender, male and female, you cannot say gender male is 1 and female is 2, because there is no numerical uh, relation, right? So that's a bad idea. So option 1 turns out to be bad for categorical data, like let's say phone manufacturer. So now let us look at option number 2. Option number 2 is one hot encoding. And one hot encoding states this: if your discrete feature, such as let's say phone manufacturer, has m values, then one hot encoding means that the way you are going to encode it is that I am going to encode it as a vector of m booleans. Now don't get scared by this, it's actually pretty simple. This just means that the first value will be represented as 1 0 0. The second value will be represented as 0 1 dot 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 0, whereas the mth value will be represented as 0 0 dot 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 1. This is what we mean by one hot encoding. So we are not directly representing, let's say, Samsung, Nokia, etc. as numbers, but we represent it as vectors of ones and zeros. So this does not confuse the ML algorithm. When the ML algorithm receives this as the input, it knows that only the first index is active, which means that it corresponds to that particular value. If it sees that only the last index is active, it means that it corresponds to that value. Since we are not assigning numbers, uh, the ML algorithm does not get confused and does not make mistakes. And that's one of the most powerful advantages of one hot encoding. So now let us look at the case of the phone manufacturers. Uh, so the one hot encoding is pretty simple. If you look at Apple, if you look at Samsung, if you look at OnePlus, and if you look at Nokia, the way I will encode these features before, or the way I'll encode these values before feeding them to the ML algorithm is that Apple will be 1 0 0 0. Why 4? Because there are four categories: Apple, Samsung, OnePlus, and Nokia. Samsung will be 0 1 0 0. OnePlus will be 0 0 1 0, and Nokia will be 0 0 0 and 1. So now these are my inputs to the ML algorithm. So this is actually called as one hot encoding, and especially it is quite a powerful trick for categorical data or categorical variables. Categorical variables means if that variable is divided into some fixed categories like survived or not survived, male or female, this or this or this or this, something like that. Let me actually take a practical example now and demonstrate to you in working practice how does this actually work. So I'm going to the VS Code right now, and I've created a file here which is called as one hot encoding.ipynb. This is a Python script which I just wrote today morning to show you one hot encoding. So we are using the scikit-learn package here, and it already gives us a predefined library which is called as one hot encoder. That's the advantage of scikit-learn, as I mentioned in one of the earlier lectures. It provides many libraries out of the box, so you don't have to specially write the code for one hot. Like you don't have to write that for the first value treat it as one, rest you can treat it as zero. Then for the second variable, put the first value as zero, second as one, and the rest as zero, etc. It just becomes very easy to write the code using libraries such as scikit-learn. I will also use a library called pandas, which is a very good library for dealing with tabular data. Tabular data just means data which exists in the form of in the table, so rows and columns. I believe in this series we have not dealt with pandas before, so this will be our first time. So let me run these initial lines of code where we just import the two libraries, pandas for dealing with tabular data and scikit-learn because we want to do one hot encoding. Now what I want to show you right now here is the base data which you have. If you look at this particular data, let's say you are a ML practitioner and someone gives you this data, right? And asks you to build a classifier, let's say. And you ask that person, okay, what is the data? And they give you this. Basically, you have four, this is just a sample data. So I'm just showing four or five entries. So each entry corresponds to one employee. It has the employee ID, it has the gender of the employee, whether male or female, and it has remarks about that particular employee, whether good or nice or great. So three types of remarks about that particular employee. And someone has now tasked you to take this data and make a classifier that classifies whether the employee is good, or let's say whether the employee is great. So think of the linear separators which we saw in the previous lecture. Before even thinking of the machine learning algorithm, first you need to think of the input features itself. Now the employee ID, uh, this is not a categorical feature, right? Because it can take any value, and it can take any value from 1 to 100, let's say. But if you look at the gender is a categorical feature because it can take only two values, male or female. The remarks is a categorical feature because it can take only three values, good, great, and nice. The question is that when you want to find the linear separator, how do you convert these into numerical values? because the machine learning algorithm needs inputs as numbers, right? Some sort of mathematical numerical representation. So for categorical values like these, how do you convert it into that representation? As we saw, one of the, if someone does not know about one hot encoding, they might just say that for male you put as 1, for female you put as 2, or for good you put as 1, nice you put as 2, and great you put as 3. But that is not a good idea, as we already saw. Option 1 of treating data as numerical attributes is not a good idea for categorical data. So this is when we will use one hot encoding for categorical variables. So first thing for using one hot encoding is determine which variables are categorical. Like gender is a categorical variable since it can take only two values, male or female. Remarks is a categorical variable since it can take only three values, good, nice and great. Okay, so now we have decided the categorical variables and we know that we are going to use one hot encoding, right? So I'm not going to go through this entire code, but I just want to uh, tell you that it's so easy to use the one hot encoder algorithm provided by scikit-learn that we just mention the table which we have, and then just we say that I want to one hot encode the vectors which are categorical. So the first statement here, it identifies columns which are categorical, and Python does that automatically. And then the second statement is that we create a data frame with the one hot encoding. So without going through the code, I just want to show you the final result of the input features which are then given to the machine learning algorithm. So keep this table in mind and now look at this particular table. You can see that the employee ID remains the same since it's a non-categorical variable, but we did not encode it. But look at uh, these two variables which were there. They have now been uh, converted into five columns. The first column is whether gender is female or not. The second column is gender male or not. The third column is whether the remark was good or not. The fourth column is whether the remark was great or not, and the fifth column is whether the remark was nice or not. So look at the first employee now. For the first employee, we have one, two, three, four, five, six entries instead of just three entries, or instead of just four entries. What are these six entries? The first is, of course, the 0, 1, 2, 3, 4, that index. The second is employee ID. The third is gender female, and this can either take 0 or 1. So here it's 0 and gender male. So this is 1, which indicates that the first employee is a male. Then remarks good. So remarks good is 1, remarks great is 0, and remark nice is 0. So essentially for the first employee, this is how the one hot encoded gender vector looks like: 0 and 1, because this is female and this is male. And this is what the remark vector looks like: 1, 0 and 0, where good, great and nice. Okay, so this is good, this is great, and this is nice. If the employee's remark was great instead of good, then this value would be 0 comma 1 comma 0, because then great will have 1 and then good will have 0. So this is how we have one hot encoded the first employee values. Now you can see for the rest of the employees. Now for the, let's look at for the this employee here. For this employee, the employee ID is 15. Uh, the gender is female. Uh, the remark is good. Then for this employee, the employee ID is 25. The gender is male, and the remark is great. For this employee, the employee ID is 30, the gender is female, and the remark is nice. Now, this encoding is amazing because now we have numerical representations and we don't have just numbers like 1, 2, 3. We have a vectorized representation. So, it will be much less confusing for the ML algorithm. And now, after this, the next step is feed it to the ML algorithm. And then the ML algorithm can take over. But before even looking at the ML algorithm, first we need to make sure that our input values are encoded correctly, especially categorical variables, which are not continuous numerical values like the employee ID. So this is the main idea behind one hot encoding. I hope you got an intuition for how one hot encoding actually works in practice. This is, by the way, exactly what is done even in big scale machine learning problems. If you have some categorical features, you one hot encode these features. Now I want to show you one more technique for feature representation, which is not generally taught in machine learning courses, and that is actually called factoring. The way I like to think of factoring is use your knowledge of the data to come up with creative encoding. So let me explain what I mean by this with a simple example. So let's say the example is that of blood groups. This is again from the MIT's course, this particular example. Let's say the example is of blood types, and we have these following blood types: A plus, A minus, B plus, B minus, O plus, O minus, and AB plus and AB minus. Okay. Now the question is, how do you encode these values when you pass it to the algorithm? Let's say you have collected a lot of data from the patient, and one data which you have collected is blood type. How do you numerically encode it before you pass it to the algorithm? The first way is to just assign integers. Like A plus will be equal to 1, A minus will be 2, B plus will be 3, B minus is 4, etc. But this is very bad for the same reason what we saw before, that there is no relation between 1, 2, 3, and 4. Does it mean A minus is greater than A plus? If B minus is 4 and A plus is 1, does it mean B minus has much more superiority than A plus? No. So there is no sense of encoding these as integers. So that does not make sense. Second, what we saw is one hot encoding. So we can encode it like there are 8 things, right? So if someone has a blood group of A plus, we can encode it like this, like this. And this is a good idea. But can we actually use our understanding of the type itself? Like we know that everything has I will have a positive sign or a negative sign, right? And everything will be either of these two categories. It will be either A, B, AB, or O, and it will be either positive or negative. So what if we encode these as a group? So what if we one hot encode this with 4 bits, and what if we one hot encode this with 2 bits? What this will do is that it will also reduce the number of features we have. Here you see we have 8 different things for every particular patient, right? But here we will just have two features. The let's say for the first patient, whose blood group is AB positive, it will look like 0 comma 0 comma 1 comma 0, and the second will look like 1 comma 0. Now this might have an inherent advantage because you are kind of encoding knowledge which you have as a human and giving it to the machine, and sometimes it may speed up the calculations. And this is actually called as factorization or factoring rather. So factoring is just basically uh, trying to factor the one hot encoding into types. So here we have factored it into 2 types. We can even factor even more actually. We can even factor even more. So one more way we can factor this particular data is in the first factoring you check whether A is present or not. In the second factoring you check whether B is present or not. And in the third factoring, you check whether you have positive or negative. That's it. So let's say here I am assuming the data only has A, B, A positive, negative, B positive, and B negative. If you have O and AB, you can add two more categories here. But the sequence is basically, do I have A, do I have B, and whether it's positive or negative. So for a patient whose group is A positive, this will look something like this. So A is present, right? So this will be 1 0. B is absent, so it will be 0 0, or rather it will be 0 comma 1, because B is absent. And then since it's A positive, it will be 1 comma 0. So even these can be the input features to the algorithm. You have a huge amount of choice here. You can, of course, encode simple one hot encoding like this. But one disadvantage of one hot encoding sometimes is that it takes too much time because we have so many values here. So that is one disadvantage. Then you can also try these things. You can use your knowledge of the data and you can use factoring. So basically, if you know something about your problem, so essentially, if you know something about your problem, if you know something about your problem, like what the inputs mean, inputs meaning, you can make a big difference to the success of the learning algorithm by taking your knowledge. So take your knowledge and you use it to encode the features, and this can make a big difference to the success of ML algorithm or the learning algorithm. So just remember one thing, right? There is a lot of creative scope. Uh, there is a lot of creative scope when you are deciding the features of a data set. So a machine learning practitioner, their main job is not just to run algorithm, but even this initial part of how you want the features to look like. So the process of being a machine learning engineer actually is very much creative. So one engineer might just use this one hot, right, and they might take a long time to get it to converge or to get some results. But another engineer very intelligently, let's say, encode some knowledge which they have and use these as input features to the algorithm, and might be they can get a better result. So the space of ML is growing so much that creativity should not be left behind. And one possible way to get creative is in selection of the features. So I'm just going to equate creativity and features. Feature selection is an extremely important step, and or I might say encoding as well is an extremely important step, and sometimes it may determine the success or failure of your entire algorithm itself. So I hope you understood one hot encoding. I did not go through too much through the factoring example because in this lecture I wanted to keep it predominantly about one hot encoding in the first place. So I hope you got clarity regarding that aspect. One final thing which I want to briefly talk about is standardization of the features. So the final thing which I want to talk about is standardizing numerical features. Now, I won't spend too much time on this, but just one thing to mention here is that let's say if you have features, right, and one feature F1 has values going from 0 to 2, another feature F2 has values going from 3 to 3000, another feature F3 has values going from 5 to 89. The problem is that if you just feed these features like this to the ML algorithm, it takes a lot of time to deal with these range of scales. So what is usually done is that it's called as standardization, or it's called as standardizing the features. So what you do is that you just take a feature, let's call it xj, you subtract the mean of that particular feature, and then you divide the standard deviation. So this is a mathematical operation for making sure that the scale for all the features is kind of the same, and this actually improves ML model performance a lot. So this is the mean. So let's say you are in F1 right now and the values are from 0 to 2. You subtract the mean and you divide by the standard deviation. This kind of makes sure that all F1, F2, F3, if you do this separately for all features, they all lie within the same range. Uh, and this is standard deviation. Now, the reason I'm telling this right now is that this simple trick of standardizing can hugely improve your ML algorithm. It can improve the speed of your ML algorithm. Uh, it can improve the accuracy of your ML algorithm, etc. So just keep two things in mind. So let's say if you are a machine learning practitioner, right, and if you have built an ML algorithm which is not working quite as well. Let's say if you have built a machine learning algorithm which is not working quite as well, you can do two things with it. You can be creative with the features, try new features. As we saw, you can implement the factoring trick to try different variations of the one hot encoding, and you could also make sure that your features are standardize the features. This is the second thing which you can do to make sure that the ML algorithm's performance will improve. So this brings us to the end of this particular lecture. To everyone who is listening, in today's lecture we covered feature representation strategies. We looked at why um, treating categorical variables as numerical attributes does not work at all. And we saw that for categorical variables, the better way to do feature representation or to do encoding before we feed the features or the inputs to the data is one hot encoding. We saw that what one hot encoding does is that it just converts the categorical variables into vectors. So there is no numerical relationship between each variable, but the value, so which index is 1 in this vector, that denotes which variable we are referring to. So for example, in Apple, OnePlus, Samsung and Nokia, this is how the one hot encoding will look like. We also saw a practical example where we have the gender, employee ID data, and the remarks. And we saw that there are two categorical variables here, gender and remarks. And using one hot encoding, we converted these into 5 columns: gender female, gender male, remarks good, remarks great, and remarks nice. So essentially, every employee which we looked at, let's say we looked at the first employee uh, who was a male. So then for the gender, the one hot encoding for the first employee will look like this: the F, which is the first value where it will be 0, and the M, which is the male, it will be 1. And since that employee's remark is good, this will be the first value will be 1, then the second will be 0, and the third will be 0. This is exactly what is done in this tabular representation over here. Towards the end, we also saw one more trick called factoring, where we saw that one hot encoding is not the only way you can go ahead with encoding features. You can also be more creative. You can use the knowledge of the input features yourself if you know what it means. And by creative factorings like these, you can tremendously influence the success of your learning algorithm by taking things you understand about the structure and using that knowledge while encoding features. Finally, we looked at standardization of features, where we subtract the mean of one particular feature and divide by the standard deviation, and we do this for all features. And it turns out that this standardizing trick can hugely improve the ML algorithm. As a conclusion, we saw that if you are an ML practitioner and if your ML algorithm is stuck or not working, you can try two things. You can be creative with the features, use the factoring trick which we showed, and secondly, you can also standardize the features to make sure that your algorithm runs faster and becomes better. So, this brings us to the end of this lecture. Thank you so much for listening and following with me. My notes and the code file which I showed will be uploaded in the YouTube information like for all the videos. Um, if you would like to continue watching the videos like this, please like and subscribe the channel, because we are posting one new video every single day. And I started this series to inspire you to learn along with me. So don't get stuck. Don't lose motivation, because I am also preparing and working for this every single day. Thank you so much, and I'll see you in the next lecture.